Now that we've solved systems by graphing, there are two other methods you need to know. One is substitution. I save that one for last because that one seems to be easier to most people. The one in the middle is solving by substitution. Solving by substitution has its advantages. You'll see as we go through what the advantage is. So let's talk about the steps, then we'll work through these. Hopefully, working through them helps you figure out the steps. So whenever we solve by substitution, you want to solve for at least one variable. You need either x equals something or y equals something. Once you have isolated that variable, because that's what we're doing, you will substitute the expression from step one into the other equation. When you do that, you should only have one variable, and you will solve for that variable. And then whatever answer you get, you'll substitute back into one of the equations, and I usually pick the easier equation, and you're going to solve. You'll write your solution as an ordered pair. Please notice that I have parentheses around my ordered pairs. I'm going to ask you to do the same thing. And then finally, you want to check the solution. What I used to do with my students is they would do a problem and they would ask me, is this right? And I would say yes to everything, even if it were wrong, because you should be able to go back and substitute what you know. So let's look at this first one, shall we? For number one, I have that x equals -4 and 3x plus 2y equals 20. And I'm going to continue my same labeling pattern here where I label these two. Step one asks me to solve for at least one variable. So if I look here, I see that the x is by itself and it equals 4. -4. So that means I'm going to take all that information and substitute it into the second equation. And I want to show that step. So I'm going to use some shorthand where I'm basically saying I will take the information in equation A and I will substitute it into equation B. So instead of 3 times x plus 2y, I have 3 times -4 plus 2y equals 20. And when I do that, I find that -12 plus 2y equals 20. And oh my goodness, now it's a two-step equation. So we add 12 to both sides. If 2y equals 32, then y equals, just kidding, that's a 32, my bad. We find that y equals 16. So I know what x is. I know what y is. So, good grief. X is -4, y is 16. And I'm actually going to check it. So when I look in the first equation, I see, does x equal -4? Yes, it does. So at least that one checks. Now let's look at the next one. Let's take 3 times -4 plus 2 times 16. And I should get 20. And yes, I do. So I know that that's correct. So I know this is my final answer. So it's really nice whenever x is just, or when one variable is just a constant, but you know that's not going to stay that way. So when I look at number 2, equation A and equation B, I see that equation A is isolated. I've got y equals by itself, and y equals all of this. So I want to substitute the information for y from the top equation into y for the bottom equation. So let's take the information in equation A to substitute into equation B. So instead of x plus y, I have x plus x minus 1. And the parentheses were just there for me to tell you this number is set apart, but now I can just start solving. X plus x is 2x minus 1 equals 3. When we add the 1 to both sides, we find that 2x equals 4. Dividing by 2 tells me that x equals 2. Okay, so I know what x equals. Now I need to find y. So look back up at your two equations. Which one looks easier to substitute into? You might say B, because you could mentally say 2 plus what is 3? 2 plus 1 is 3. And that works great. If you can do that, more power to you, dude. But I just want to be sure that I'm substituting properly. I know that x equals 2 and 2 minus 1 is 1. So it looks like y equals 1. And I do believe we just did all the work. So I don't even need a calculator for this, I'm tripping. Does 1 equal 2 minus 1? Yes. And does 2 plus 1 equal 3? Yes. So that's my right answer. And I can move on. Number 3. Again, I look at equation A and equation B, and I see that equation A has an isolated variable. So I want to look at all of this. So all of that is really x. So I can go into my second equation and substitute for x. So everything from A will substitute into B. So instead of 3 times x, I have 3 times all this craziness. But I have to bring my plus 15y, I bring my equals, I bring my negative 1. So now I'm going to distribute. I'll get negative 15y plus 12 plus 15y equals negative 1. See how I forgot that y in there? I know what's coming up, so I know that I made a mistake. And let that be a lesson to you. Please make sure you bring everything over as is. So let's look at it again. 3 times x plus 15y equals negative 1. Upon distributing the 3, I get the expression negative 15y plus 12 plus 15 equals negative 1. Now I need to combine like terms. So negative 15y plus 15y, well, those will zero out. When those zero out, I'm left with 12 equals negative 1. And when does 12 equal negative 1? Never. That's a false statement. So I say that the solution here is no solution. And what does no solution look like? Well, you know in a graph that it's parallel lines. So it's parallel lines whenever we look at a graph. But here's what it really means. It means that there is no ordered pair that makes both equations true. Okay? You can't check both. You know how I substituted up here? Check, check, and then I check. Well, it may check one of these, but it will not check the other one. That's what I'm saying by no solution. That's what I mean by no solution. All right, so let's look at number 4. When I have equation A and equation B, I see that x is isolated here, so I want to put this together. And all of that will substitute in there. So my information from equation A will substitute into equation B. So instead of 2 times x, I have 2 times 5y plus 10 minus 10y equals 20. Did I do this correctly? 2 times x minus 10 times y equals 20. Yes, I did. So now we're going to distribute, and I get 10y plus 20 minus 10y equals 20. Okay, I have my like terms. They're going to zero out. I'm left with 20 equals 20, and guess what? That is a true statement. Because that's a true statement, I say that this system has infinitely many solutions. What that means is there are many ordered pairs that check both. And what does the graph look like? Well, it's a line with another line directly on top. So I've heard them say they're coincident lines, same line. That's what you need to know. Okay? So that's where we are there. Now I want to look at number 5. I have for equation A and equation B. On this problem, it looks like the variable that's isolated by itself is y in the bottom equation. So I'm going to take the information from the bottom equation and substitute it into the top equation. So I have 3 times x plus 2 times y, but y is now x minus 1. And that will equal negative 12. All right. So I will bring down my 3x plus, I will distribute my 2. That equals negative 12. Combining like terms gives me 5x minus 2 equals negative 12. And to solve, I will add 2 to both sides. And I find that 5x equals negative 10. And so x equals negative 2. So far, I know x is negative 2. I've got to find what y is. And I'm going to go into the second equation. If y equals x minus 1, x is negative 2. And negative 2 minus 1 equals negative 3. So I believe I will complete my ordered pair with negative 3. So let's check it. We're going to take 3 times x, which is negative 2, plus 2 times y, which is negative 3, and please let me get negative 12. Yes. So that one checks. And now let's check the second one. Does y equal x minus 1? Does negative 3 equal 2 minus 1? Well, I know it does because I'm good at mental math, but just for those doubters, negative 2 minus 1, does it equal negative 3? Ding, ding, ding. Yes, it does. So guess what? That means this is my right answer. And I always, once I do all this work, it would really suck for me to do all the work, get the right answer, but I've got everything in such a jumbled mess that I don't see this. So I somehow make a note. If I had glitter, I would put a line of glitter around this. Lights, flashing lights, whatever. Just this says, hey, robe deer, that's my answer. And because I've boxed it up, I stand by my answer. Okay? So that's how I look at things. All right, so finally, let's look at number 6 here. Again, I use my usual labeling here of A and B. Where is my variable isolated? The bottom equation, and it is x that's being isolated. So that will substitute for x in the top equation. So the information in equation B substitutes into equation A. So instead of 2 times x, I've got 2 times negative 4y plus 8 minus 5 times y, and that will equal 29. So I'm going to distribute here, negative 8y plus 16 minus, I bring down my minus 5y, that equals 29. I've got like terms here, negative 13y plus 16 equals 29. We will subtract the 16 from both sides. Negative 13y equals 13. So y equals negative 1. So y is negative 1. And now let's look into equation B. X equals negative 4y plus 8. Okay, so it's negative 4 times negative 1 plus 8. That's 4 plus 8, which is 12. I think that's the right answer. But I won't know for sure until I check it. So let's check it. So I think it's going to be 12 negative 1. So let's look up here. 2 times 12 minus 5 times negative 1. Do I get 29? Yes. Yes, I do. Now, does x equal this? So x is 12. Does 12 equal negative 4 times negative 1 plus 8? Boom. Yes, it does. So guess what? This is my right answer. I stand by this answer because I plugged it in. So I taught my son 8th grade when we started systems. And there were a couple of instances where he gave me negative 1 comma 12. That's wrong. You should be able to plug it in to see that you got the right answer. And, if I do that to my own flesh and blood, yeah, it's more important. Okay. So I do want to practice these, a few practice. It's on the back of your notes. I think what I'm going to do is I'm going to work through the odds just so that you have an idea, without all of this up here distracting you. Okay, so we're just going to do the same thing again. This is equation A. This is equation B. I see that my y is isolated, so it's going to substitute there. So the information in equation B gets substituted into equation A. So we have 2x plus 8 times y equals 20. 2x plus 16 equals 20. When we subtract the 16 from both sides, we find that 2x equals 4, and so x equals 2. So it looks like my order pair is 2, 2. It's not a done deal yet because I make mistakes. Y'all have seen them. You don't know how many video edits I've had to make. So I need 2 times x, which is 2, plus 8 times y, which is 2. I should get 20. I get 20. And when I look at my order pair, does the x coordinate equal, oh, my bad. Does the y coordinate equal 2? Yep, it does. So boom, there it is. It's the right answer. Now let's look at number 3. Again, I see a variable that's already isolated. It's right here. So that means I'm going to substitute that information from equation B into equation A. So B subs into A. And I really do this for my benefit because if I want to go back and figure out what I did wrong, well, my first step is I take what's in B into A. And a lot of times that helps just by figuring that little piece out. So I have 5 times x minus 2 times y. But in this problem, y is 2x. And that equals 3. So I have 5x minus 4x. Whoa there. That equals 3. I combine my like terms. 5x minus 4x is 1x. And so x equals 3. So I'm halfway there. I know x is 3. I need to solve for y. So out of these two, which one looks easier to substitute into? Which one looks easier to solve? Well, I'm lazy, so I'm going easy with B. So equation B is y equals 2x. But I know that x is 3. So it looks like y is 6. And I think I'm right. But again, my good friend TI here is going to help me. So I have 5 times x, 5 times 3. Minus 2 times y, which is 6. I should get 3. Yay, and I do. And let's double check this. Does y equal 2 times x? Does 6 equal 2 times 3? Yes, it does. So, boom, I'm right. Okay, we're moving along swimmingly. And notice they're sort of changing things around, which is what we do in math. I'll notice for number 5, it doesn't look like a variable is isolated until I see that all this crazy equals x. So x is isolated in the bottom equation, but it's not isolated in the way that you normally think. So x will substitute here. So the information in B will be substituted into equation A. So instead of 4 times x, we have 4 times y minus 9 plus 7y equals 19. So when I distribute, I have 4y minus 36 plus 7y equals 19. So when I put these together, 11y minus 36 equals 19. I'm adding 36 to both sides. I find that 11y equals 55. When I divide both sides by 11, I find that y equals 5. So guess what else is so cool here? Not only am I teaching you substitution, but I'm reteaching solving equations that need like terms or that have like terms, solving 2-step equations, solving 1-step equations. It's like it's a kitchen sink problem. It's got a little bit of everything. Okay, and so now I need to find the value of x, so I'm going to use equation B. If y minus 9 equals x, y is 5. 5 minus 9 equals x. 5 minus 9 is negative 4. So I think my solution is negative 4, 5. So let's check it. So 4 times x, which is negative 4, plus 7 times y, which is 5. Does that equal 19? Yes, it does. Yes. Now I'm going to take y minus 9, 5 minus 9. That should equal negative 4. And boom, it does. So guess what? That's right. All right. So far, so good. Everything seems to be moving along nicely. Now I want to look at number 7. I'll leave this here just for those of you that might need a moment to look. So when I look at problem number 7, I see that out of the 2 equations, the variable is isolated in equation B. So y equals all this. So all of this information for y will be substituted into the top equation for y. So B substitutes into A. I have 2 times x minus 8 times y, minus 8 times negative 7. Oh, whoa there. My bad. Negative 7 minus x. That equals 6. Let me double check because when I make a mistake, I get nervous. 2x minus 8y equals 6. All right. It looks like I've substituted, so let me carry everything through. 2x comes down, and doggone, I'm going to have to distribute a negative. So I'm taking negative 8 times negative 7. That's a positive 56. And then I'm going to take negative 8 times negative x, which is a positive 8x. And that will equal 6. So 2x plus 8x is 10x. Plus 56 equals 6. So now I'm going to subtract the 56 from both sides. And I find that 10x equals negative 50. When I divide by 10, I find that 10x equals negative 5. So if x equals negative 5, I've got to find y. So I look at equation B, where y equals negative 7 minus x. And oh my goodness, I've got to be very careful here. I bring down my negative 7. I bring down my minus. And I substitute negative x, which is negative 5. And I'll get negative 7 plus positive 5, which is negative 2. So I believe my solution is -5, -2. So let's see if that works. 2 times x, -5, minus 8 times y, which is -2. Does that equal 6? Yes, it does. And let me look at this. Does y equal this? So let's take -7 minus x. And x in this problem is -2. And I get -5. Does that equal -5? Yes, it does. So this is my right answer. All right, I'm good. So I've done the odds so far. I'm going to talk about number 9, but I also want to show you number 10 because this is what graphing looks like. This is what graphing is. I'm going to plot this, well, not this one, but like this is slope-intercept form, this is slope-intercept form. I'm basically saying, when does -6x minus 3 equal -x plus 2? This is the algebraic form of graphing. It really is. Okay, so let's look at number 9 first. I'm getting ahead of myself. This is so exciting, y'all. So if I start to talk fast, bear with me. It's exciting stuff. So I see here that x is isolated in the top equation. So I will substitute it into the bottom equation. Could I have substituted this into here? Sure. Same thing. So A gets substituted into B. So instead of x equals, I'm going to get -y plus 3 equals -3y plus 5. And now look what happens. I have an equation with the variable on both sides. I've always taught that you get rid of the smaller variable first. And the reason I do that is to avoid having any negative variables left over. So to get rid of -3, I'm going to add 3 to both sides. I find that 2y plus 3 equals 5. Now I'm going to subtract the 3 from both sides. I find that 2y equals 2, and so y equals 1. And now I need to solve for x. So x equals 3 times y, or 3 times 1. -3 plus 5 is 2. So it looks like when x is 2, y is 1. Let's do the math to make sure. So x is 2. So when I take the negative of y of 1 plus 3, do I get 2? I do. And when I take -3 times my y coordinate of 1 and I add 5, do I get 2? I do. So guess what? That is my right answer. So you see what I'm doing there? I'm just setting the two equations equal to each other. That forces me to have an equation with variables on both sides. So I'm still doing the same thing. Do y'all notice I'm doing the same thing every time? I find an isolated variable and I substitute that information into the other. I'm not saying top or bottom. I'm saying find one, go into the other. It works. If I substitute top into bottom or bottom into top, so be it. I'm still taking one and plugging into the other. So here, if you want to, I'll do this one. Y is by itself, and it means all of this. So all of this will go in for the y that's there. So when I take the information from equation B and I substitute it into equation A, I have -6x minus 3. It equals y, but y equals -x plus 2. So I have an equation with variables on both sides. So I'm going to add 6x. And when I do that, I'm left with -3 equals 5x plus 2. Now I'm going to subtract the 2 from both sides. And and I find that negative 5 equals 5x. And so I want to divide by 5, and I find that x equals negative 1. And when I substitute this into equation B, the negative of x plus 2 equals y. If 1 plus 2 equals y, then 3 equals y. And I've totally run out of room here. I think my order pair is negative 1, 3. So let's try it. So we're going to take negative 6 times, we'll take negative 6 times x, which is negative 1, minus 3, and I'm going to get 3. I did, so that one checks. Then I'm going to take the negative of x, which is negative 1, negative of x plus 2, and I should get y, which is also 3. So that's right. So I know this is my right answer. Okay, so what's the moral of the story here? The moral of the story is isolate a variable in one equation. Substitute that into the other equation. Solve for one variable. Substitute again. Solve for the other variable. Write your order pair. But please, please, please check your answer. And I use this anytime I see a variable by itself. Anytime there's a variable by itself, I use substitution. It makes my life easier. Just remember, you always want to check your answer. And that's it.